In calculus, we often encounter integrals that are products of two different types of functions. While basic integration rules fail here, a powerful technique called integration by parts allows us to break these complex expressions down into manageable pieces. This technique is essential for solving problems in physics and engineering, such as calculating the energy in a decaying signal or finding the center of mass of complex shapes. It turns a difficult product into a simpler subtraction. To understand where the formula comes from, we start with the product rule for derivatives. By integrating both sides of this equation and rearranging the terms, we derive the fundamental formula for integration by parts. Here is our primary tool, the integral of u dv equals u times v minus the integral of v do. Our goal is to choose u and dv so that the new integral on the right is easier to solve than the original. Choosing the right u is critical. We use the Liate rule as a guide. Generally, you want to pick u as the function that becomes simpler when differentiated, and the dv's as the part that is easy to integrate. Before calculating, always set up a small table. This organization prevents sign errors and ensures you have all for components u, v, do, and dv ready to plug into the master formula. Geometrically, integration by parts can be seen as calculating the area of a large rectangle and subtracting the area of the region above the curve to find the area beneath it. It is a mathematical trade-off. Let's try a classic example, the integral of x times e to the x. According to Liate, the algebraic term x should be our u, and the exponential e to the x will be our dv. Now we differentiate u to get do equals dx. Then, we integrate dv to find that v is simply e to the x. We now have all the ingredients required for our formula. Plugging these into the formula, we get x times e to the x minus the integral of e to the x. Notice how the new integral is much simpler than the one we started with. The integral of e to the x is just e to the x. After adding the constant of integration c, our final result is x times e to the x minus e to the x plus c. We have successfully integrated the product. Sometimes the second function is hidden. To integrate the natural log of x, we treat it as ln x times 1. Here, u is ln x because it is logarithmic, and dv is 1 dx. Differentiating ln x gives us 1 over x, and integrating 1 gives us x. When we multiply v and do inside the new integral, the x and 1 over x cancel out perfectly, leaving us with just the integral of 1. The final answer is x times the natural log of x minus x plus c. This trick of using the 1 as your dv is a vital tool for integrating inverse functions and logarithms. Be careful! If your new integral looks more complicated than your original one, you likely swapped your choices for u and dv. If that happens, stop, go back, and try reversing your selection. In summary, integration by parts is the reverse product rule. Always use Liate to pick your u, keep your work organized in a table, and remember that some problems require more than one application of the formula. Test your knowledge in the integral of x cubed times ln x, which should be u. If you chose ln x, you're correct. Logarithmic functions take priority over algebraic ones in the Liate hierarchy. Integration by parts is a skill that improves with practice. Master this, and you'll be able to tackle a wide variety of calculus challenges. Thank you for watching. Generated by Vision Solve AI.